जी सर.
Yes. So now we need have, sure, no problem, no problem. Okay. So now now I am just try to draw the parts. Okay. So at first from S to everyone, careful, X, S and Y at first. So just if you write the derivation, that is, it is very easy to draw the parts. If you draw, if you write the derivation, that time it is very easy to draw the parts. Isha is present in the classroom. Isha or Khondokar Fahim. Hello. Hello. Am I audible?
Yes, sir.
Yes sir.
Yes, sir.
Okay, that means they are not present. Okay, from X to X, S and Y. Okay, no problem. Okay, then this X to lowercase x and uppercase x. That is this one, like this one, and this one is actually this one. Okay, so just a minute, just a minute. Actually left and oh, just a minute. So this one actually two, left and right, that is actually x and capital X. So no problem. Okay, so done. Then this x to null or epsilon, not is it? This x to epsilon, is it? Everyone? This x to epsilon.
Yes, sir.
So you
Yes,
need to
sir.
write epsilon. Okay, I think now for your concept is problem is solved. I think I don't know actually. Okay, so this one, okay, done. This one done. Then you need to write S to Z. That means S to Z. Okay, S to Z. Then which one? Y to YY, lowercase y and uppercase y. Everyone draw this one. Y and Y, is it? Okay. Then this Y2 again YY, is it? Sorry, just a minute. This one YY and this Y2 again YY, is it? That means actually, just a minute. That is actually Y. Then this Y2 epsilon. That means this Y2 epsilon. So this is your parts. So X epsilon Z epsilon, X epsilon Z, then Y, then again Y, then again epsilon. And epsilon means actually nothing. So this, our output is X Z Y Y. So when actually epsilon single, that time you need to write epsilon. Suppose A epsilon, so you don't need to write A epsilon. Okay, got my point. Suppose A epsilon, that is actually A. But when single epsilon, that time you need to write epsilon. When it is single, okay? When epsilon it is single, that time you need to write epsilon. Otherwise, it's not mandatory to write epsilon. Got it, everyone?
Yes, sir.
Everyone.
Yes,
How
sir.
many students in the class now?
31.
31. That means
29.
30. That, yes. Okay. For next to আমরা কি করব? What actually I don't know. But they should join the class. Okay, so parts is clear, concept is clear, the concept of parts T, everyone.
Yes, sir.
Any confusion? No. So this one is your homework again, this one. Oh, এটা তো homework ছিলই, তাই না? এটা কিন্তু আপনার like ambiguous. So it is possible to get more than one left derivation. For this, so this one actually also your homework, actually was your homework actually. Just So this one actually also your homework, and I think many of you will solve this one. So this one actually ambiguous grammar. That means there is actually more than one leftmost derivation for this input string. Is it? Anyone solve this one? Hello? Anybody? Anyone? Hello? Hello?
No, sir.
Why no? But that one actually your homework, and I gave this homework in the last class. Is it? Anyone actually tried to solve this one, or nobody? Hello?
স্যার আপনি খাতায় লিখি নাই আমি দেখছি
Sorry?
খাতায় করে করি নাই আর কি এমনি দেখছি
Who you are? Just me.
Sir, Isha.
Isha. Okay, Isha. So Isha. Okay. So but this one again your homework. Okay.
ওকে স্যার
Okay. So Isha, you got the last parts of the last one. The last one.
ইয়েস স্যার
I draw the parts of the last one.
ইয়েস স্যার ইয়েস স্যার
Got it?
ইয়েস স্যার
Okay. So today we will discuss a new topic that is actually left recursion. Okay. So till now your midterm syllabus. Okay. So now I am going to no. Just
Sir. স্যার আমাদের কি এক্সাম ডেট চেঞ্জ হবে?
Your exam date?
স্যার এটার তো এক্সাম ডেট স্যার এমনিতে যেটা অফলাইনে ছিল ওটা তো 10 তারিখে ছিল।
Yes. Now the exam actually online. That's why your date will be changed. And
Yes,
that
sir.
will be next Tuesday or Wednesday, because you have only 2-day class, Tuesday or Wednesday.
Sir, which will be better? When is this one?
And I will notify you.
Okay, sir.
Okay, no problem. So representative of grammar. So what is representation of grammar? Actually, look at the grammar. So your grammar also actually maintains precedence and associativity. So we know that first bracket has the highest precedence. That's why it is at the lower level. Then multiplication, then plus. And we also actually notice this tend at the time of syntax tree. So in syntax tree, highest the precedence, lowest the label, like that. So here also actually we can see that if the precedence is highest, that means it situated at the lowest level. Then this one, then this one. That means this one has the highest precedence, then this one, and then plus. Okay, everyone? Hello?
স্যার রিপিট এগেইন
Okay, so actually this grammar, so your context-free grammar also maintains precedence. So if you think your actually syntax tree, if the precedence is highest, that means that is actually at the lower level. Is it?
ওকে
Think.
স্যার
এটা ওকে না, আপনি থিঙ্ক করেন, আপনি তো আগে পড়ে আসছেন। দেখেন সিনট্যাক্স ট্রি এর লোয়ার লেভেলে যেটা থাকে তার কাজ আগে হয় না, তার মানে তার প্রেসিডেন্স বেশি না।
জি স্যার
Yes, sir.
Yes. So here actually the precedence of first bracket is actually highest. That's why it is actually at the lowest level. Then the precedence of star, that means multiplication, then the precedence of plus. That means highest the precedence, low is the level. If you think the level, that means this is the lowest level, then this
So
one,
we
then this.
cannot see your screen.
Oh really?
No, sir.
Sir, we can.
No, sir, it's visible, sir.
Maybe his network.
Please
I'm
rejoin.
checking now.
Please rejoin. So got it, everyone? This one actually highest the precedence, lowest the level. Okay?
ওকে স্যার
So representative grammar. So this is the last topic of your midterm syllabus. So your midterm syllabus finished. Okay? Hello? Actually your midterm okay, got my point? Okay.
ইয়েস স্যার
Okay, just a minute. Okay, so actually now our concern is left recursion. So we know that actually there are two types of actually parser, top down parser and bottom up parser. So top down parser actually from root to bottom, that means root to lips, like this, root to lips, that is actually top down parser. And bottom up parser means actually lips to root, lips to root. So if you consider this one, yes, so this is actually top down, so from here to here, then like that. So this is actually, you can consider, so it is actually from root to bottom, that means root to lips, that is actually, this is actually top down parser. Okay, got it? And bottom actually means actually lip to root, that is actually bottom up parser. Everyone got it? So actually there is a actually problem of grammar, that is actually left recursion. And what is left recursion, I will discuss, no problem. But if your grammar has left recursion, if your grammar has left recursive problem, then it is not possible to construct top down parser. So your top down parser cannot work with left recursion. So what is left recursion, I will discuss now, no problem. But if your grammar is left recursive grammar, then your top down parsing is not able to work. That is important. Okay, then what is left recursive grammar? Just give me time and I will explain. So at first you need to know what is recursion. What is recursion? What is recursion? I think you know what is recursion. What is recursion? Yes, that means call itself, call by itself. That is the recursion. So suppose if you consider the first production rule, so that is actually E to E plus T. Is it? That means E replaced with E plus T. That means E call itself. Then again E plus T. Then again E plus T. Then again E plus T. That means E actually call E. So this is actually recursion, and the growth of the tree on the left hand side, not right hand side. The growth of the tree actually on the left hand side. So this is known as left recursion. Okay, so this one is actually known as left recursion, everyone. So if your grammar looks like this one, that is actually left recursion. So just a minute. So concept clear why it is called left recursive?
Yes, sir.
Yes. And now I will tell a shortcut how you actually understand this grammar or this production rule is left recursive. That is actually very easy. When this one and this one is same, that means this one and the leftmost one same, and both are non-terminal, that is actually left recursion. Okay, both should be same, and both should be non-terminal. That time we can call it as left recursion. Okay, everyone, both
Yes,
are
sir,
same
yes, sir.
and both are non-terminal. That means this is actually left recursive production rule. So we can actually write a general formula, that is A to A alpha or beta. So this is actually general form. So this is actually general form of left recursive production rule. Here A and A are same and both are non-terminal. That is actually, this is left recursive production rule. Got it, everyone?
Yes, sir.
Okay. So,
Yes, sir.
So this, just a minute. So this one is left recursive or not?
Yes, sir. Left.
Left recursive.
And this one is left recursive or not?
Yes, sir.
Yes, sir. Left recursive.
And this one?
No.
No, sir.
No, sir.
No. Yes, what? Hello?
Because F
Alpha
and E
means
are not
actually
same.
alpha means actually anything with A, that is alpha. I will discuss, no problem. And beta means actually present absent of A, that is actually beta. Okay, no problem. I will explain at the time of elimination. Okay, no problem. Okay, so this one is a left recursive or not? This one?
No, sir.
Not sir.
No. No.
This one?
No, sir.
No.
This
sir.
one?
No.
No, sir.
Sir.
This one? No, this one no. So this one actually non-left recursive grammar. Okay. This one is non-left recursive. Okay. So this grammar is suitable for top-down parsing. So when actually, when your grammar, your grammar actually have left recursive actually problem, that time actually you need to actually solve the problem of left recursion. That means you need to eliminate that left recursion. Okay, and we know that this is the general form. This is the general form of left recursion. Okay, this is the general form of left recursion, and this is the problem of compiler design. And we need to solve the problem of left recursion. Okay, everyone?
Yes, sir.
Just a minute. So by looking this one, we can easily understand this one is actually left recursive. Easily, because both are non-terminal and both are same. So this one actually is known as immediate left recursive production rule. Immediate. Just see and take decision. There is left recursion present. Just see and take decision. Okay, everyone. After seeing this one, you are able to take decision. This one is left recursion. But sometimes, so look at this one. Just a minute. Look at this one. So suppose your production rule like this one. Suppose your production rule like this one. Suppose like this one. Okay. So this one is left recursive.
Yes, sir.
No. This one is left recursive.
No, sir.
No, but this one is left recursive. How? Because here S is the non-terminal. S is the non-terminal, and you can replace S with A, D. Now this is left recursive.
Yes, sir.
Yes. So sometimes by seeing, just seeing, you can take decision that this is actually left recursive. And sometimes you need to wait. You need to wait for some derivation. And after that derivation, you will see there is a left recursive problem. So there is two types: immediate left recursion, and another one actually after some time you will feel that there is a left recursive problem. Got it, everyone? Everyone got it?
Yes.
So
Yes,
there is
sir.
a case. If there is a case, that means after seeing this production rule, you are able to take decision that there is a left recursive problem. And sometimes you need to actually take decision after some derivation. There is a left recursion problem. Okay, so that's why actually this one actually used this notation. That means equal plus means actually after some derivation. So actually plus means actually we know that one or more. That means you can actually just by seeing the production rule, you are able to take decision that there is a left recursion problem. And sometimes after some derivation, that this problem can arise. Is it? That's why equal plus. That means after some derivation, if you get A to A alpha, that is actually left recursion. Okay, everyone?
Yes, sir.
Everyone? Okay. Okay, done. And left recursion, we know that is a problem of compiler design. So we need to eliminate this problem. Okay?
Sir, why it is the problem?
Yes, yes. because it will produce infinite loop. There is a possibility to produce infinite loop. That's why it's a problem. Okay, I forgot to mention this one. Thank you so much. So actually in the last slide, I will draw, actually I draw actually a figure like this one. Just call it by itself, So there is a possibility of actually infinite loop. That's why it's a problem. Okay?
Okay, sir.
Okay. Okay, no problem. I will draw that T again. So we can consider this one. So we can consider this one as left recursive production rule. Is it this one? A to
Yes,
A
sir.
alpha beta. So suppose you can go alpha to beta at first. Okay, no problem. That means your input is beta. You can go like this one. A alpha. Okay. Then suppose beta. Okay. Then you can go like this one. And so on, like then A to alpha, then again A to alpha, then again A to alpha, then like beta. So actually this one actually indicates actually beta A star. Why A star? So suppose this one only beta, this one beta alpha, this one beta more alpha. That means 0 or more alpha. So this one actually is able to generate this input. Is it? Everyone? Hello? Actually, this production rule is able to generate this input. That means beta and alpha actually star. That means 0 or more alpha. Okay. Hello?
Yes, sir.
Yes,
Got
sir.
it? Okay. So suppose there is a problem of a tree. So it is better to cut down the tree or solve the problem without cutting down the tree. Which one is better? Just cut down the tree or
Solve the problem.
without cutting
Cut
the
down
tree?
the tree, sir.
Yes.
So
So
cut
that is
down the
actually
tree, sir.
now that is my concern. So this type of production rule will produce these types of actually input, but this grammar is left recursive grammar. So now we are trying to change this production rule, so that you need to change this production rule in such a way so that you can generate this input string as like before, but there is no left recursion. Okay, got my point? So your new updated production rule able to generate this input, but left recursion will be absent in the newly generated production rule. Okay, got my point? Everyone? Got my point? Now you need to actually make new production rule so that you are able to generate this input, no problem. But the newly generated production rule actually no left recursion problem. Okay? Everyone? Okay. Hello?
Yes, sir.
Okay.
Yes, sir.
Okay, so our input is beta alpha star. That means actually you can go A to beta A dash. That means A dash actually a new actually non-terminal. That is A dash. And you can go just A dash to, that means now you get beta, no problem. Your beta is done. Now you need to actually produce actually alpha star. That means alpha A, and obviously you need to actually put a epsilon. Okay, just a minute. So this production rule is able to generate this beta, and this production rule is able to generate 0 or more alpha. So when you replace the first actually left recursive production rule with these two, that means now it is able to generate the same input string but without left recursion. Okay, got it everyone? When you replace this production rule with those production rule, then you are able to generate the same input like before, but there is actually left recursion is absent. Now everyone, hello, so our left recursion problem is solved here. Got it everyone? Why? Please response.
Oh, sorry. The last one is not clear.
Last one.
Yeah, last one is not clear.
Okay, just a minute. So you will just a minute. I will give an example. No problem. So this one is replaced with those. So you will push in actually. Sorry. So you will push in with this one. Hello.
Yeah, yes, sir.
Yes, yes. So actually, suppose you want to produce beta, alpha, alpha. Suppose. Okay. So suppose you need to go. Suppose A to B alpha, B A dash. Okay. Then you can replace. So you need alpha. That means you need to go A dash to alpha A dash. That means beta alpha A dash. You need another actually alpha. That is actually you need to go beta alpha alpha A dash, and you need another alpha. That is actually beta alpha 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 A dash. So we don't need more alpha. That means you can replace this A dash with epsilon. That is actually beta alpha alpha alpha. So it is possible. So with those production rule, it is possible to generate the string like this. Now clear? So when you replace this type of production rule with these types of production rule, then your left recursion problem is solved. At the same time, it is possible to generate the same string. Okay, everyone?
Yes, sir.
Yes.
Abu Bakr,
Yes, sir.
clear?
Yes, sir. But why are we writing EBA like A dash? What is the important of it?
Yes, sorry.
A dash like beta A dash. A dash means what?
A dash actually you try to solve this problem. Okay, is so if you try to solve any problem, so you need to actually perform some operation to solve this one. So that's why to solve this problem we take a new non-terminal, that is A dash, so that we can solve the problem of left recursion. We take a new we take help of new non-terminal, that is A dash. Okay, we take help of a new non-terminal, that is A dash. Abu Bakr, it is
Okay,
new.
sir, I understand.
It is actually a new non-terminal, and we take the help of this new non-terminal to solve the problem of left recursion. Some actually here epsilon come, some, that means we insert some symbol to solve the previous problem, like that. Okay, everyone? Abu Bakr, now clear?
Okay, sir.
Okay, so when actually your production rule looks like this one, that means a left recursive problem, if you replace this one with those, that means actually your problem is solved. So I think, just a minute, so x plus y plus z plus suppose k. Suppose I think this type of problem you solve in your actually, just a minute. So we know this formula. And this type of problem suppose come in the exam hall, suppose in your intermediate or high school level. So that time we actually change this one, we like this one, so that we can apply formula. So we change like x plus y, then z plus k whole square. Now you can consider this one as a and this one actually b, is it? So those types of problem we solve in our high school level, is it, or intermediate level? Hello?
Yes, sir.
That means if actually your equation is not actually like the formula, that time you make this one so that you can apply formula. Is it, everyone?
Yes, sir.
Yes, sir.
Okay. And this is actually your intermediate or high school name.
সাইট এক্সাম্পল দিবেন।
Yes, আমি example দেব, এখনই দেব, সমস্যা নেই। So suppose this is your standard form, that means this is your formula. Okay, so this one actually is a left recursive production rule, is it? This one is your left recursive production rule. So this is your standard form. So you need to actually make this formula like this one if you want to apply the formula. Okay, so this one actually a. So if you consider the formula, this one actually a, is it?
Yes, sir.
Compare with this one. So this one actually a, and anything with a, that is alpha. So this plus t, that is actually alpha. Got my point? Anything with a, that is actually alpha. That means plus t actually alpha. Got it?
Yes, sir.
And
Sir.
when a is absent, that is actually known as beta. When a is absent, that is actually known as beta. So here a means for this production rules, a means
E.
e. So suppose et, so this is beta or not? Suppose
Yes, sir.
te beta or not? So just a minute, suppose et, so this one is beta or not?
Yes, sir. Beta.
No beta. So beta
E
means actually the absent of a, that is actually beta. So but there is presence of a, and here a means e. So this one actually not beta.
Present.
So that means et is not beta. But actually there is actually only t. So we can consider t as beta.
স্যার ইটি
Okay.
হলে কি ওটা আলফা হবে?
হ্যাঁ
স্যার ইটি হলে কি ওটা আলফা হবে?
ওটা হবে তখন a আলফা, আবার ইটা হবে a এবং টিটা হবে আলফা। ওটা এরপরে স্লাইডে আছে, সমস্যা নাই, বুঝছেন আমার কথা এভরিওয়ান? সো অ্যাবসেন্স অফ a, that is actually beta. Okay, so this identification is very important. If you are able to identify a, alpha and beta, that time it is very easy to solve the problem of replication. Then simply apply the formula. The formula is a to beta a dash. And what is a here? What is a?
E.
E. That means e to. Then beta means
T, sir.
T.
t. Then a dash means e dash.
E dash.
Okay, got it?
Yes, sir.
Then the second one, a dash, that means e dash. Okay, then alpha a dash. So what is alpha? Plus t.
Plus T.
Plus t. Then a dash, that means e dash, is it? Then epsilon. So now this production rule is replaced with those production rule, and there is no left recursion problem. Got it, everyone?
Yes, sir.
Everyone?
Actually, sir, can you please clarify when we use beta and when we use alpha? Like absence of a, we use beta, and presence of a, we use alpha, right?
Yes. Actually, with a, that is alpha, and absence of a, that is beta. Abu Bakr?
Yes, sir.
Yes, please. Then please ask question.
Yes, sir. In the absence of a is beta, right?
In absence of a, this there is beta. Yes. Then
And when we have alpha, is it standing for A and all things with A, all the components with A?
all things actually. So plus T, that is actually alpha.
Okay,
This is divider actually. This is divider. So you cannot consider T with this one. Okay. You cannot think
sir.
this T with this one. This is another production rule. E to T and E to E plus T. That means two production rule. So E plus T, that means plus T is the alpha. Plus T is the alpha. Okay. This part is the alpha. Got it, Abu Bakr?
Yes, sir, I got it.
Yes, sorry, please ask. Sorry, hello. Or that is not concern from now. Got it or no? Okay, done. So our fast production rule actually, actually left recursive. That's why we need to actually solve the problem of left recursion of the first one. Second one is left recursive or not?
Yes, sir.
So the second one is also left recursive. As this one is left recursive, we again actually solve the problem of left recursion. So at first we need to identify what is A, what is alpha, and what is beta. So this one is A. This one is A.
Yes, sir.
This one is A. That means anything with A, that is actually alpha. That means into F, that is the alpha. And F, this one is beta, because here T is not present. Suppose TF, that is not actually TF, that is not actually beta. Okay, everyone?
Yes, sir.
Okay. So then it is very easy. So try to apply the formula A to beta A dash, and A is actually T. Then beta means actually F. Then A dash, that is T dash. Okay, everyone?
Yes,
Yes.
sir. Yes.
Okay.
Yes, sir.
Okay. Then A dash, that is actually T dash. Okay. Then alpha means actually into F, star F. That means into F. Then A dash, that is actually T dash. Okay. Then epsilon. So when you replace this one with those, that means actually the problem is solved. The problem of left recursion is solved. And this one is left recursive.
Sir,
No. Yes.
last line, the first T bar 2, is it asterisk?
Which one?
Last line, sir.
Yes, this one.
Yeah.
Yes, this one actually, this one. Okay. Hello.
Can you please again? Can you please explain last line, sir? I understood up to last line. Last line T bar equal.
So you need to look at the formula. The first one is done. So second one is A dash to alpha A dash, and A dash means T dash because here A is T. Everyone, here A is T. Yes.
Sir.
Huh? Hello.
Yes, sir.
Yes, sir.
Yes. Then actually alpha, and alpha is actually asterisk F. That is the alpha. Abu Bakr. That means you need to put asterisk actually F here. That is the alpha. Asterisk F is the alpha. So we need to put asterisk F first because this is the alpha. Then A dash, that is actually T dash. Okay. Then a bar or then epsilon. Okay, got it, everyone?
Yes, sir.
Now got it?
Yes, sir.
And the third one has a left recursive problem or not?
No, sir.
No, so we do not need to change this one.
No, sir.
So this one actually is the answer. Okay, so this grammar actually have left recursion problem, but we now solve so that there is no left recursion. There is no left recursion. Okay, everyone.
Yes, sir.
Yes, sir.
Okay. Okay, I need to discuss about a very important topic. Just a minute, and just 2 minutes. Not okay. Just a minute. So about our actually extra class when.